Okay, this is a quick little video about single core, dual core and multi-core CPUs. So processor is kind of like the brain of a computer, and it has a speed, a clock speed in gigahertz. So you've probably heard 2 gigahertz, 3 gigahertz, 4 gigahertz. Well, that's kind of reaching the maximum of what processors can reach without getting too hot. So what the manufacturers decided to do is create dual core and then multi-core processors, which means there's more than one processor on a chip. So you used to have one little processor, little bits on it, that's single core. Then they created a dual core, which had 2 processors on it. Then you got quad core, etc. Now, each one of these is its own separate processor. And if you remember how a processor works, it fetches the data it needs, decodes, executes, goes through all those processes. Now, with a single core, it can only do one of those things at a time. With dual core and multi-core, it can do 2 or 4 of those things at a time. Which means that even if each individual processor isn't as fast, it can do more than one thing at a time. The issue with that, of course, is not all programs are designed to take advantage of this. But if you've got a program that can use more than one core, it's optimized, you get a huge speed increase. So, for instance, say we've got a 2 gigahertz processor, 1.6, 1.6. You'll notice that I'm putting the multi-core one slightly lower. That's kind of how it works. Now, if you're using a piece of software that's not optimized for using more than one core, it will only use one at a time. So we've got not optimized. So this could be a game or an application, and it's actually in the design phase where they're deciding whether they optimize it or not. Nowadays, most of them will use it because you don't get many single core processors, but that's what we have. You get a lot of single core processors in phones. So 2 gigahertz, it means that if it's not optimized, a single core one will run at 2 gigahertz. The dual core one will only run at 1.6 gigahertz. The quad core one will only run at 1.6 gigahertz because it can only use one of them at a time. If it is optimized though, if they've designed it to take into account all these different cores, the single one will still run at 2 gigahertz. The dual one can run at up to 3.2 gigahertz. And the quad core one will run at up to 6.4 gigahertz. Now, it wouldn't always be more than 3 times the speed, but theoretically, that is what it could run up to if the program was designed to take all that into account. So if you've got a program that uses multitasking, so doing lots of things at a time, like video encoding or 3D design, or even some modern games, they will really take advantage of multi-core and dual core processors. It will run a lot faster, you can do a lot more things at once. And that is different core processors.